Alrighty, welcome to Introduction to Statistics. I'm going to try really hard to say that word correctly, even though I might struggle. And we're going to be talking today about collecting and classifying data. So, statistics is basically about gathering information and using that information for a particular purpose. For example, governments, universities, businesses, and NGOs, charities are a type of NGO, non-government organizations. They all need to collect data in order to work properly. It's just very important. We all need to know it. You need to know it to read the news and to understand what's happening in the world. In India, I read a story about the government collecting data about tigers and how many tigers were left in the wild. Tigers are an endangered species, so that's why people need to collect data about them so that they know how are they going. If they're doing something to make sure tigers are not going to die out, then are they succeeding or not? And the government collected the data, and the universities wanted access to the data because they wanted to make sure that the government was giving accurate information and using good methods. So that was a big discussion from when I read the article. So some questions that data can answer are: how many tigers are there in a country or an area? What do tigers eat? How big is a tiger's territory? Basically the places where it goes on average. So the way they answer these questions is they attach a collar to a few tigers, and they use the collar to track them to find out where they're going and what they're doing. And we're going to see very soon that what's happening here is they've got a population of tigers, which is all the tigers in the country, and they're just choosing a few tigers and studying them, and that will give them information about the whole population. That's the idea. Okay, so now we're going to get into what are the terms used in statistics. What are these words and what do they mean? So population is a group of something. It's usually a large group. For example, the whole group of tigers, or it could be the number of the people in a country, or all the cars in Melbourne. And basically, we are collecting data about a population. So it doesn't need to be people. It could be people or animals or objects. But we're collecting data about usually this big group of things or people. So collecting data from the whole population is called a census. That's what happens when they... anytime you collect data from the whole population, so for example, asking every single person in the population, how tall are you? Although they wouldn't ask that question. They would ask them something more useful, but I can't think of anything more useful at the moment. So it's very difficult to ask every single person in the population a question, because you need to make sure that they all answer the question. It's very difficult to do. So basically, we choose a small part of the population, which is called a sample. So you can see here's the population here of a group of people. And there's so many people, it would take them a long time. It would take us a long time to ask them all questions or to write down information about all of them. So we'll just choose a few people, a sample, and we basically select them at random. I've selected these people randomly. It's difficult to do this, and I've included a little bit of extension at the end talking about why it's so difficult to do that. Okay, but anyway, we select the people at random, and then we collect data from the sample instead. So instead of collecting data from the whole population, we just collect data from these 5 people, and we assume that what we collect is similar for the population. By the way, let's do a quick test here. How many people have glasses? 3 people out of 5 have glasses? How many people in the population have glasses? 1, 2, 3, 4, 5, 6, 7. Hopefully I haven't missed any. 7 out of... How many have we got? 1, 2, 3, 4, 5, 6, 7, 8. 7 out of 46. So we assume the data is similar for the population. That's not necessarily true. This is about 60%. And this is about 15%. It turns out that if you have bigger populations and bigger samples, then you're more likely to get an accurate number, as in the sample is more likely to have a similar percentage to the population. But this is what we do. We always choose a sample, and choosing a sample is really hard, getting it right so that it's the numbers of similar to the population. It's very difficult to do. All right. Sometimes we can't even make a sample. Sometimes we don't have the time or money or influence. And so all we can do is make an observation of some data that we can see. For example, let's say you want to find out what do people in Australia think about climate change, and you don't have enough money or time, and you're not really allowed to necessarily. You don't have enough money or time to ask everybody in Australia. You don't have enough money or time to even ask a sample, a big enough sample so that it would be accurate. So, or any sample at all. So all you can do is look on the internet and read some articles written by people in Australia to find out what people think. But you can see this is even less accurate because you've only got a few people writing these articles, and you don't know why they've chosen to write those articles. So this is even less likely to give us an accurate picture. So you can see the best thing is to ask everybody in the population, do a census. The second best thing is a sample. But your sample has to be big enough, and it has to be chosen at random, which is difficult. I'll tell you about it later if you're interested. The third thing, which is the worst option, is just observation. All right. So this is all assuming that you're doing the data collection yourself. But sometimes you don't do the data collection yourself. Sometimes you get the data from somewhere else. And we have two types of sources. Sources are somewhere where you get the data from. A primary source is the best. This is where you get access to the original data. It's all there. You can see it very clearly, and you can use that data. Secondary is where somebody else has taken the data and they've made a summary of it, and they've put it into graphs and they've kind of explained it for you, but you don't have access to the original data. So somebody would have used some data, like in a document like this, to make this graph, but you don't have access to that. So primary data is the best because it's more trustworthy, and if you make a graph of it, if somebody else has made a graph of it, they've made choices in making that graph, and they are giving you a version of the data that might not necessarily be helpful. But it's better than nothing. Well, unless they're trying to trick you, in which case it's worse than nothing. So primary is the best. Secondary is okay if you trust who it is. Okay. So variables. There's a lot of vocabulary here. I'm sorry about that. But we need to get this out of the way before we can talk about the topic properly. So variables are basically the information we collect from the population or the sample. So let's say one type of information is shirt color and another is height. They're both variables. And you can see that the shirt color changes depending on who I look at. And the height changes. Well, we can't see the heights, but the height would change depending on who you look at. So it changing or varying, that's why it's called a variable. Depending on who I look at, it's different, it changes. Okay, so there's two main types of variables. So one of them is numerical. So that's if the information is in numbers, you're probably looking at a numerical variable. So height, for example, that variable gives us a number for each member of the sample. So it's a numerical variable. If we use the variable to put people in categories or groups, then it's called a categorical variable. So shirt color, for example, is a categorical variable because we can put people in groups or categories. For example, yellow, white, blue. We don't have any blue shirts here. But we can put people into these categories or groups, and we can count how many people are in each category or group. So categorical and numerical variables. Now, it gets slightly more complicated basically because there's two types of numerical variables. So if I start with variables, remember we split it into two sections, two different types. There is categorical and numerical. And there's two types of numerical. So one of them is discrete, and one of them is continuous. Oh. No E at the end. All right. So discrete, okay, let's start with continuous because we've already talked about it. Heights are continuous. The reason for that is because you can have an infinite number of heights. I'm 196 centimeters, but I'm 196 point something. Maybe it's 3, 2, I don't know what it is. 3, 2, 5, 7. And you can keep going with this decimal. Somebody else could be 156.210. Can you see, because I'm allowing decimals, there's infinite number of heights that somebody could be. On the other hand, discrete, let's put that over here as an example of that. Discrete could be, sorry, that's heights. Discrete could be number of children somebody has. Discrete means there's only a limited amount of options. They're still numbers, but there's only a limited amount of options. So you could have 0 kids. You could have 1, 2, 3. And there'd probably be an upper limit somewhere. I'm not really sure what that is. What am I doing? So 0, 1, 2, 3. And you can see that I'm not allowing decimals here because you can't have 1.5 kids. You can't have 1.37 kids. You can have 0 kids, 1, 2, 3, ... So if there's decimals, basically it's continuous. If there's no decimals, it's discrete. Okay, now we're up to extension now. So if that was all too much or a lot of information, just take a break. At least take a break, do some questions, test yourself, test your knowledge. If that was all fine for you, if you knew a lot of that before, or you think you could understand everything quite easily, then have a think about this. I just want to talk about why selecting a sample at random is difficult. Remember we had the... Where is it? The population and the sample. And we had to choose these 5 people. It's actually very difficult to choose them at random. And here's why. And this is useful for later on. You have to learn this later on anyway, so it's good to be exposed to these ideas earlier. Let's say, for example, that we're in a company and we sell regular petrol and diesel cars. And we are interested in finding out how much Australians want to buy electric cars. How interested are people in Australia in electric cars? Because if they're very interested, maybe we should start making them. But if they're not very interested, then maybe we just wait. So there's 25 million people in Australia, and we want 1,000 people to complete our survey. So that's a sample, isn't it? This 1,000 people is our sample. And can you see it's a lot more than 5, so we're probably going to get more accurate results because we have more than... If we only had 5 people, our results would be not useful at all. But if we're choosing 1,000, maybe we can be more accurate. So the question is, though, if we put out an ad for the survey, so maybe we advertise online, we say complete this survey, what type of person is most likely to complete it? If you were looking at online on the internet and you're looking at an ad for a survey for electric cars, you're probably not going to waste your time with it unless you're interested in electric cars. But can you see there's a problem here? And I'll just illustrate the problem with an example. Let's say 500 out of 1,000 people in the survey, so you got your 1,000 people, they all answered the survey, and 500 of them say that they would buy an electric car if the company made one. Right, so that's 50%. But let's say in reality, now I say only, this is such a big number, but think about the percentages. That's what's the most important thing. Only 250,000 out of 25 million people in Australia would buy an electric car. That's 1%. So you can see that the survey told them 50% of people would be interested in buying one. But in reality, only 1% of the population. These two numbers are not matching up at all. So this data is not very useful. And the reason this might have happened is because the type of people who filled out this survey, they were already interested in electric cars. So the survey wasn't actually random. That was the problem. The survey had this thing called bias, where it actually wasn't a random selection of the people. It was a selection of people where a lot more people than usual were interested in electric cars. That was the problem with this survey. That's why it's so difficult to make a random selection, because people only decide to answer the questions if they have some reason for doing that. And to make this a little bit more easy to be random, sometimes people say they're going to pay you for the survey. And if somebody pays me for the survey, it doesn't matter whether I like electric cars or not. I'm more likely to do it just because I'm going to get paid. So that's one way that people make the selection of the sample more random, by paying people. All right. Now, don't worry so much if you didn't understand that. I do want you to get the basics though. So you might want to rewatch a section of this video if you are confused about any of these words. So just to go over it again: population, sample, observation, primary and secondary sources, variables, and the different types, numerical and categorical, and even further, the 2 different types of numerical variables. That's the basics, and that's the main thing that I want you to get out of this video. All right. I will see you another time. See you later.